Hello everyone, how are you all? So today we are going to discuss all the DPPs of periodic table 1 to 9. Okay, so let's get started. Which orbital are filled in given order in fifth period of periodic table? Okay, so few students will not be aware of the concept, so it's okay, no problem. Those who have studied from me, no issues, they can just grasp, and few students have not studied from me, it's okay. So with every question I will explain you the concepts also. So take a notebook, pen, paper and start writing concepts related to each and every question. Believe me, 80% of thing will be cleared after solving all these DPPs. Okay, let's start. So which orbiter are filled in given order in fifth period of periodic table? So whenever they are asking you the order, now the simple concept is fifth period they are asking. So in the start we will write down S, at the end we will write down P, okay va, and S and P always have the same principal quantum number. Fifth period it is indicating principal quantum number and value, okay va. Sixth period means 6S 6P, fifth period means 5S 5P, fourth period means 4S 4P, clear? Okay, so those who don't know they can note down. So fifth period when they are asking, so I will write down here 5S and 5P, and you should remember two more star point what I have taught you. As soon as I will say fourth period, danger sign. What is the danger sign? That d orbital will be included, and how to write down d orbital? N minus 1 d. N means the highest principal quantum number. So if I am saying fourth period, so who will come bacha? 3d. If I am saying fifth period, so in between who will come? 4d. Very good. Let's say now another dangerous sign where what I should remember, sixth period. As soon as I am saying sixth period, we have our d orbital. Now here f will also come. So what I will say, and f how to write down? N minus 2. Okay. So here 5f 6 na, so here not 5f, here 4f 5d and 6p will come, okay va. Let's say for example I am saying 7th, so what I will do, how I will do, I will write down here 7s, at the end I will write down 7p, and one less will be our d, so I will write down here 6d, and one more less, that is our 5f. Are you able to understand? Okay va. So now you shall tell me, in between 5s and 5p who will come? 1d, and d should be always less than. So here our 4d will come. So what is the answer? First option will be the right option. Okay. Next, the number of element in fifth and sixth period of periodic table are. So very easy way. First you remember, and if you can't remember, then how we will solve. So when I am saying you here fifth period, okay, so who will come in fifth period? Just now I have told you 5p, 5s and 1 less than 5, 4d will come. In P maximum, how many electrons I can fill? 6. We know na, P has 3 but 3 orbital, each orbital 2 electron. In D maximum, 10 electron, in S maximum 2. So 6 plus 10, 16 and 16 plus 2, 18. So in fifth, how many element maximum? 18. Now what they are asking you, bacha? Sixth period. So I will write down here 6s, 6p, and in between sixth, f will also come, right? So I will write down here 5d and then 4f, okay va. So 6s means 2 elements, f means maximum 14 I can fill, d means maximum 10 I can fill, p means maximum 6 I can fill. Those who don't know, learn here itself along with the questions. P maximum 6 electron, d maximum 10, f maximum 14 and s maximum 2. So you just add it. So 14 plus 6 our 20, 20 and then 30, and then 30 plus 2, 32, where we have 18 and 32, option number C, correct? Okay. Now let us see here question number 3. The period number in the long form of the periodic table is equal to, just now I have told you period number is equal to principal quantum number n value, maximum value of principal quantum number. Let's say I am saying 1s, 2s, 2p, 3s, 3p, 4s. So 4s. So we will see the last one, the maximum one. Okay, va? So the maximum principal quantum number represent the period number. Okay. So what is the option? Magnetic quantum, atomic number? No, 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 no. Maximum principal quantum number? Yes, ma'am. The period number is equal to maximum principal quantum number of any element in the period. C option. Question number 4. According to modern periodic law, the elements with similar chemical and physical properties repeat at regular interval, okay. When the elements are arranged in the order of, always remember, only in case of modern periodic table, only the modern periodic table was based on atomic number, rest everything was based on atomic mass. So, what I will say, atomic number, fourth C option. Now, let us see question number 5. If the atomic number of an element is 33, it will be placed in the periodic table in which group? Okay, so what I have told you, okay, I have told you whenever they are asking you group number, period number, block number, whatever they are asking you, just go to inert gas, where we will go inert gas. What are the inert gas? Helium, neon, argon, krypton, xenon, Rn, Og, it will go so on. Okay, ba? So helium 2, then 10, then 18, then 36. These are the atomic number, you should remember. So and which period we start from helium? First period, second period, third period, fourth period, so on. Okay, ba? So 33 they are asking. So where it will fall, bacha? 33 will fall in the krypton period, will like before krypton it will. So it say, let's say here it is 36. So just before 36 who will come? 35. Before 35, 34, and before 34, 33 will come, and for 33 only they are asking. And we know this helium, neon, argon, krypton, xenon is nothing but 18th period. Okay, va? Sorry, 18th group. So after 18th group who will come here? 17th, and then before 17th who will come? 16th, and before 16th who will come, bacha? 15th. So 33 belongs to which group? 15th group. So fifth C answer. Clear? Okay, good. Now let us see question number 6. It takes only like I am explaining you, so it is taking too much of time. Once you will start practicing, now it will take only 10 seconds to write down helium, neon, argon, krypton, xenon, and then analyze. No need to use any formula. It will waste more time. Okay, it will come with practice. Next, question number 6. Which of the following pair of element belong to a representative group of element in the periodic table? So I have told you representative groups means the main element, that is S plus P block elements. Okay, ba? All S and P blocks are known as representative group element. So aluminum Al P block, magnesium Mg our S block. Yeah, so first option itself we have got, right? Chromium and zinc beta, it is D block element. Okay, argentinum, astatine, okay, lanthanum, thorium, no. So they do. So in every option we have other than S and P. So first option is the right option. Next, question number 7. The element which belong with chalcogen family is, tell me fast quickly, what do we mean by chalcogen family? Chalcogen family means oxygen family. Who all come in oxygen family? Oxygen, sulfur, selenium, tellurium. Okay, so sulfur, 7th C. Next, chalcogen oxygen family. Those who don't know, remember oxygen, sulfur, chalcogen oxygen family. Now question number 8. All the S block element of the periodic table are placed S block. S block are placed in first group and then second group. So where is first and second group? Very chumma question, DPP 1 now. So it will be easy only, 8th A option. Okay. Now let us see question number 9. Which one of the following statements are related to the modern periodic table is incorrect? Okay, let us see. Incorrect they are asking. In your NEET exam now, they will just twist the questions. Which of the following is incorrect? Which of the following is not correct? Which of the following is not incorrect? Okay, so you have to pay attention. The P block has 6 column. Yeah, in P block maximum how many electrons you can fill? 6. So what? How many column? 6 column. Okay, ba? Because a maximum, yeah, because reason is also correct. Okay, because maximum 6 electron can occupy. So this is correct. D block maximum 8 column. In D block total 10 columns are there, because in D block how many we can fill? Maximum 10 electrons. So B is the wrong option. Next, C, each block contain a number of column equal to number of electron. Yeah, there is a concept actually. So each block contain number of column equal to their number of electron. Like S, how many maximum electron? 2. Those who don't know, note down. P maximum 6, D maximum 10, F maximum 14, and these electron is equal to their column. Okay. The block indicate value of azimuthal quantum number L for the last subshell that receive electron in building up the electronic configuration. Yeah, this is also right statement. Okay. So the block indicate value of azimuthal quantum number for the last subshell. Okay, wow. So you just check the last subshell, and that last subshell value azimuthal value indicates the block. Okay, clear? Now let us see question number 10. An element has atomic number 37. The block and group of the element. Now you can do fast quickly. Where we will go? We will go to our inert gas 18th group. So I am writing my 18th group. Inert gas helium 2, neon 10, argon. Now you should remember it. Okay, 18, helium, neon, argon, krypton 36. We will stop here. Okay, because it is 37 only they are asking. Okay, wow. So you can write down full also, helium, neon, argon, krypton, xenon. Okay, 54. So let us see. So they are talking about 37. Bacha, 37 will come here after 36, means here, right, in the starting, in the next first period, second period, third period, fourth period, fifth period. So it is coming in sixth period. Okay, wow. So period we have got sixth. Next let us check the group number. So 37 is coming in the S block. After the end of 18, who will come again? First group, right? First group, second group, and first group means we are talking about S block. So S block, first group, and our sixth period. So first group and S blocks. Option number A for question number 10. Now let us see question number 11. The element with atomic number 117 and 120 are yet to be discovered. In which group would you place these elements when discovered? Okay, so here we have, I am writing again quickly, helium, neon, argon, krypton, xenon, radon, Og. Okay, ba? So Og is 118. Okay, ba? Og is 118. What they are asking, bacha? 117. So pakka 117 will be just before Og, that is 118. Okay, so first, second, third, fourth, fifth, sixth, seventh period. So before Og, here. Okay, before Og, seventh. Seventh period. So it is seventh period, but they are asking you about the group. So this is our 18th group. So just before 17th group. Okay, so 117 belong to 17th group. We have one more trick to solve. Just first we are going conceptually, then I will tell you the trick also. Then 120. So 120 will come after 118, means here 119 and here 120. So this is our first group and this is our second group, means S block. So our answer should be for 120 second group and for 117 17th group. So 17 and 2. So question number 11A. And one more trick you can write down, that from 113 to 118, you just see the last two digit, it will indicate your group number. So directly we can see. So 117. So what is the last two digit, bacha? 17, right? So what will be the group number? 17. Easy. Okay, so now let us see our DPP number 2, which is mismatch regarding the position of the element as given below. So Z equal to 89 F block. So you should remember the range of the F block. Okay, so those who don't know, please write down. So F block will always belong to third group, first start point. Okay, now in this third group we have sixth period and seventh period. Sixth period is our length and wide series, seventh period is our actin wide series. For length and wide series the range will be 58 to 71, and actin wide series the range will be our 90 to 103. Okay, now let us solve question. So 89 belong to F block. What is the last limit, bacha? 71 is for length and wide and 90 is for our actin wide. So 89 is not our F block. Okay, this is wrong. Then 100 belong to F block. Yes, till 190 to 103 is our F block elements. Clear? So and it is seventh period, also belongs to actin wide. So this is also correct. Next let us come to 115. So I have told you just now what trick. 113 to 118, see the last two digit. So 115, the last two digit is 15, mean it belongs to 15th group, and 15th group is our P block element, not the D block element. Clear? So which so means A and C both are wrong. Now let us see question number 2. So this you remember, this is very important. Okay, length and wide 58 to 71, actin wide 90 to 103. An element has 56 nucleon in nucleus, and if it is isotonic with Y, okay, 60-30, which group period does it belong? Group and period we have to find out. They are talking bacha isotonic. Isotonic means same number of neutron. Okay, ba? So an element that is has 56 nucleon. So its neutron is 56. Or nucleon is 56. So nucleon means neutron plus proton. Okay, value is given how much bacha? 56. Okay. Now, and it is isotonic. Okay, means number of neutron of Y is equal to this element who has 56 nucleon. Clear? Okay. So let us find out for Y the number of neutron. So how to find out number of neutron? Number of neutron will be A minus Z. A is mass number 60 and Z is atomic number 30. This we are finding for Y. So for Y we have got 30 neutron, and they are saying that Y is isotonic with 56 element, atomic number 56 element. It means that neutron of this element is also 30. So I can say N plus P equal to 56, that is 30 plus P equal to 56. So P will be equal to 56 minus 30, that is our 26 number of proton, and we know bacha number of proton is nothing but atomic number. Okay, so they are talking about which element? The element whose atomic number is 26. Now we will use our concept of helium, neon, argon, krypton, xenon. So helium, neon, argon, krypton. Let us wait here because it is only 26. So here we will get our 2, 10, 18, 36. So 18 means it will come after 18, means it will come somewhere in the this period, the krypton one. Okay, va? So let us, I am writing little down here. So after 18, 19, 20, then we will have 21. Okay, va? Then we will have 22, then we will have 23, then 24, then 25, and then we have our 26. Okay, va? Now let us see here. So just to count. So first group, second group, third group, fourth, fifth, sixth, seventh, and then eighth group. So 26 is coming in which group beta? Eighth group. So what will be the answer? Eighth group. And let us check the period. So 1, 2, 3, 4. It is coming in the krypton period, the fourth period. Clear? Easy. So this is how you are supposed to solve. Now let us see question number 3, 2 mark question. IUPAC name of the element which is placed after 105. So after 105, 106, that is anilhaxium. Where is anilhaxium? C. Now let us see question number 4. In the long form of the periodic table, all the non-metals are placed under, P block. Metals are placed under, in general we are talking about metals are placed under S block. Transition elements D block. Okay, what? P block contain metal, non-metal, metalloids, everything. But in general, non-metals are placed in P block. Symbol for the element 114. So U quad, 4 for quad. So Q, U Q. Option number 1. These are very simple question. What is the other name for group 18th element? Okay, so what is the name of a group 18th element? Noble gas or inert gas. Next, which group element are called transition metal? So transition metal means D block. From where to where? S block is our first group, second group, and then 3 to 12 here is our D block, and then 13 to 18 is our P block. Okay, so 3 to 12. Where is 3 to 12? C belongs to D block transition metal. Which of the following element belong to alkali metal? Alkali metal means last orbit subshell must contain 1 or 2. Like first of all, it is not, they are not asking about S block. They are only asking about alkali metal. Alkali metal general configuration bacha S1. Alkali metal general configuration S1. See, where is S1? Here is S1. So option number B is the right answer. Next, question number 9. The element with atomic number Z equal to 115 will be placed. Just now I have told you the trick. 113 to 118. See the last two digit. What is the last two digit? 15th. 15th means which group beta? 15th group. Which option? C option. Okay, va? Then and how to check the period, just now I have told you. So 15th, so you can think of about OG. OG is 118 and which is in the last period, 7th period. So before OG only 116, 17, 16 and then 15 will come, 7th period. Okay, wow. Next, the electronic configuration of D block. What is the general electronic configuration of D block? NS12, N minus 1, D 1 to 10. In general NS2, but some exceptions are like chromium, copper, where NS1 we will take to maintain the stability. Okay, so option number 1 is the right answer. Okay. Now let us see DPP number 3. Sixth period of the modern periodic table, electronic energy level will be. So just now I have told you sixth period. So we will have our 6s, 6p. In between who will come? D and F. D will be 1 less, F will be 2 less. So we will have our 5D and then who will have 4F. We can solve this question in one more ways there to solve. You learn this also because it is important. How to learn according to the energy level, how to identify, because they are asking in this question energy level only. So how to check energy level. So here is the concept I am writing here as a star point. N plus L value is more, so energy level will be more. And if n plus L value is same, then we will check n value. More n value, more will be energy level. Those who don't know n is our quantum number. Which quantum number? Principal quantum number. So this number 6, 4, 5, 6, they all are telling us quantum number, principal quantum number. And this SPDF is telling us about the azimuthal quantum number L value. I am writing here. For S, L value 0, for P 1, for D 2, for F 3. Okay, wow. So 6s, so n will be 6, here n will be 4, here n will be 5, here n will be 6. Now L value 0, L value for F bacha 3, L value for D bacha 2, L value for P 1. Okay, wow. Now 6 plus 0, n plus L 6, n plus L 4 plus 3 7, 5 plus 2 7, 6 plus 1 7. Now you see n plus L value is same, then how we will check principal quantum number. So more principal quantum number, more will be energy. So and this is a concept behind say. So I have told you very quickly 6s, 6p, in between our 1 less D and 2 less F will be there. Okay, but how to arrange, actually this is the concept. Next. Okay, so let us see question number 2. An element has electronic configuration xenon 4f7, 5d1, 6s2. It belongs to block. So we have two methods to solve this question. The first method is you arrange these things in the energy order and see where the last electron is, where the last electron is entering, or where the first time the electron is filling in the last orbital, which is the last orbital where the electrons are going, or which is the last subshell where electrons are going, and that will represent to our block number. Okay, wow. So let us see here. Or the second method is you add all the atomic number and then you just see which block it belongs. So let's say for example xenon atomic number 54. 54 plus 7 plus 1 plus 2. So 54 plus 7 plus 1 plus 2, it will come around 64. Okay, so it will come 64. 64. So do you remember I have given you a range 58 to 70. Okay, 1. It will belong to F block, and anyway 64 is gadolinium GD. So F block, it belongs to F block. What is the another way of solving this question? You use this n plus L value and then solve it. Okay. Next, third, according to the IUPAC system of naming element, the symbol of the element of atomic number, Arichumma question, U and then B and then U, U, B, U, C. IUPAC name of the element with atomic number Z109. So 109 nil in UNE, D option. Okay. The element having electronic confusion, again they are asking block. So first time we have solved using adding the atomic number. This time let us arrange it and then let us solve it. Okay, so let us arrange 4 plus D. Okay, so 4 plus D for 0, 1, 2, S, P, D, 0, 1, 2. So 4 plus 2 will come. Here 4 plus 3 will come. Here 5 plus 0. Here SP. So 5 plus 1. Here 6 plus 0. Okay, ba? Now let us. So 4 plus 2 we are getting here 6 and then 7 and then 5 and then 6 and then 6. Okay. So we will arrange according to energy increasing order, lower to higher. So 5 as 2, after that 6 things will come, but among 6 who will be lowest? 4. Okay, then who will come? 5p. Then after 5p who will come, bacha? 6s. And then last who will come? 4f, 14. So now you see the last electron is entering in which subshell? F subshell. Okay, ba? So which group it will, which block it will become? F block. And what is the second method I have told you? You add the atomic number of everything and then you check. Both methods are there, whichever you feel easy you can solve. I feel this more easier. Okay. Then let us see question number 6. The element with the lowest atomic number that has a ground state electronic configuration of n-1 d to the power 6 ns2 is located in the. Okay, so they are asking you lowest atomic number that has a ground state electronic configuration. So they are asking you that lowest atomic number means where we will introduce the d block. Just we have introduced the d block lowest, no? That means they are talking about the first d block. So can you please tell me what I have told you as a danger sign? In which period we introduce the d block? Fourth period. Okay, ba? Where is fourth period? C option. Question number 7. Which of the following set of atomic number correspond to element of group number 16? So group number 16 means oxygen, sulfur, selenium, tellurium, polonium. Okay, ba? So it will come here 8. Okay, so what is the magic number? 8, 8, 16, 16, 32. It will be there. So in 8 we will add 8. So what we will get here? 16. Now in 16 what I am going to add? 18. So what I will get here? 34. Okay, then again 18. So what I will get here, beta? 52. So 8, 16, 34, 52. Option number C. You don't have to remember the all atomic number. Just remember this, the first, second period. Okay, wow. After that you just add 8, 18, 18, 32, 32. 8, 18, 18, 32, 32. Okay, wow. Okay, let us solve question number 8. So they are asking you period number and group number of 73. Okay, so how we will solve? We know our helium, neon, argon, krypton, xenon. We can solve, but we know one more thing. It's like this is how you should proceed in your exam. Like easiest way, we should look for the easiest way, and it will come according to the practice. So we know that 58 to 71 belongs to which group, bacha? Third group. Okay, so after 71 only 70 to 73 will come, so it will become easy for you. After 71, 72, then 73 means it is our fourth group and fifth group. Okay, ba? So 73 will come in the fifth group. So this is the answer, and it is coming after length and wide, that is sixth period. So question number 8, and you know helium, neon, argon is there, we can use it and solve. Consider the following electronic configuration. The correct statement about the element P is. Okay, so we have to tell which period and which group it is belonging. Okay, so again you do the same way. So last electron is going into our f orbital. Okay, so it belongs to f group. If f group, f block, it is belonging from f block. So f block means, bacha, third group and sixth period. Third group, sixth period. Question number 9. How we are saying sixth period? By saying the highest principal quantum number. What is the highest value of principal quantum number? 6. So it is sixth period, sixth period, sixth period, sixth period, and last electron is entering into 4f. So it is our f block, third group. So ninth, C option. Then let us see question number 10. Which orbital are filled in the given order in fifth period? Again same question. You know what you will do. 5s and then 5p. In between 5 who will come? 4d. 10th A. Till now from 6th only F start. 6th, 7th only F. 6th, 7th only F. Okay, ba? So DP number 3 over. Now let us proceed to DPP number 4. Okay, so in DPP number 4, so till 1, 2, 3 we have seen general questions like block number, period number, group, all those things. Okay. Now let us see about the size. Okay. So for size, I am just telling you in short, left to right, size increase, down the group, size decrease. The next star point, if isoelectronic species means a species with same number of electrons are given, then we will say minus, more in size than neutral, more in size than plus. This is the second star point. And third star point, that some exceptions are there like boron family, then 3D series we have exception, then 4D is equal to 5D, all those due to lengthenoid contraction. That's all. Only this much is, those who have studied from me, they will understand within fraction of 1 second, 3 seconds we have done the revision of size. Okay, let us proceed. Which is the smallest in size? So what is the trick, bacha? So more negative, more will be the size. So who is having less negative charge here? C. So first C answer, within fraction of second we have done. Which of the following is largest size? So with the positive charge, it is negative, then neutral, and then positive. More positive, lesser in size. So neutral will be bigger than any other positive. If you have to arrange, how will you arrange? Al, then Al plus, then Al plus 2, then Al plus 3. Are you able to understand? So more positive charge, less size, more negative charge, more size. Covalent radius, they are saying radius is 99 picometer. Select the best representation of chlorine. So I have taught you covalent bond is represented like this. Okay. And okay, this is our internuclear distance. Okay, fine. And metallic are represented like this, and van der Waal are represented like this, little far. So covalent means overlapping must be there. And they are asking you covalent radius of chlorine. For chlorine it is 99 picometer. So for Cl2 how much, bacha? This much only is 99. So for Cl2 it will be 99 plus 99. Okay, 198. So see, 90 wrong, 198 and like this overlapping. Okay, so B option is the right option. 198 from here to here. Okay, let me check. Oh, I'm so sorry. That's why we should not do in hurry very. Okay, but from here they have told no internuclear distance, very wrong. Okay, so which option? C option, internuclear distance. This will be the right option. Now question number 4. The radii of F minus O minus 2, just now I have told you, bacha, more negative charge, more will be the size. Okay, so negative, then who will come? Neutral, then who will come? Positive. So negative will be better, definitely, minus and O minus 2. So O minus 2, then F minus, after that who will come? So we know carbon, nitrogen, oxygen, fluorine. So left to right size decrease. So who will be better? Oxygen will be better than fluorine. So O minus 2, F minus, O and F. I think fourth A option itself is right option. Okay. Now let us see question number 5. The correct order of radii is, okay. So first order is nitrogen, beryllium and boron. So let us arrange it nicely. So how to arrange in periodic? You should, that entire periodic table should be in your brain, then only you can solve the question. So beryllium, then here boron, and then we have carbon, nitrogen and all like this. So beryllium, boron and nitrogen only we have to compare. So left to right size will decrease. So beryllium, then boron and then nitrogen. So this is wrong option, right? Beryllium should be more. Next let us see fluorine, O minus 2, N minus 3. Yeah, it is right only. More negative, more is the size. Next lithium, potassium, sodium. So lithium, sodium, potassium, down the group size increase. So potassium will be more than sodium. So this here it is wrong. Then again plus 2 plus 4 11. So understood? Question number 6. Ionic radii are directly proportional to effective. Ionic radius is inversely proportional to Z effective. More Z effective, more force of attraction. So more force of attraction, so size will decrease. Okay. So inversely, directly proportional to square of effective nuclear charge, very bad. Inversely proportional to, yes. Sixth C option. Okay, let us see question number 7. In an anion, they are talking about anion. So how to form anion, bacha? By adding electron, right? When we add electron, so negative charge will be there. So anion, and when electron will come, repulsion will be there. So size will increase and effective nuclear charge will decrease, because we know just now we have seen size is inversely proportional to Z effective. Option number 1, proton we can't touch, neither increase nor decrease. Proton we can't remove, neither add. Proton more than electron, we are adding electron, so electron should be more. Wrong option. Effective nuclear charge is more, no. More size, effective nuclear charge decrease. Radius is larger than neutral, just now I have told you, negative, neutral, positive. Those who are not understanding this negative, neutral, positive, na, you see I have made so many tricks on this, so you just go to my shorts and then you see there I have made a detailed lectures. Which of the following, detail in the sense it is just 1 minute only, but yeah, you will be able to understand everything. My 1 minute lecture is also detailed to understand each and every concept clearly. Next, which of the following pair of element have almost similar atomic radius? So I have told you 4D and 5D will become almost similar due to length-wide contraction. So who all are 4D, 5D elements? Zircon, Zr, HF, MOW, CO, Ni. So all of this. Okay, ma'am. Okay, so now let us solve question number 9. Which of the following sequence is correct for decreasing order of ionic radius? Okay, so here now you can't use that trick because not all are isotonic species, right? Selenium, iodine, bromine, so huge differences than electrons in number, so we can't use the direct trick more minus. Okay, and then again I minus, Br minus, F minus, how will you do? So we will arrange it, normal common method. So how to arrange? Selenium, let us say it is oxygen family, so oxygen, sulfur, selenium. Okay, then we have fluorine, chlorine, bromine, and then iodine. Okay, wow. What are the things given? They have given O minus 2 and F minus, and then sulfur is not there, selenium is given, chlorine is not there, bromine is given, iodine is given. So we know beta, down the group size increase. So who will be maximum? Definitely iodine, I minus will be more. And now when we are talking about this selenium and bromine, they belong to the same period. When it is same period, now both are isotonic, right? Se minus 2, Br minus 1, both belong to the same period. Then here I can say that Se minus 2, because of more minus charge, it is having more size. So after iodine minus, who will come? Se minus 2. Then who will come, bacha? Br minus 1. So always arrange it same period. You can check your electron, more minus, more size, but down the group size increase. So let's say fifth period will be more than fourth, fourth will be more than third without any exception. Exception is where in D block element 4D, 5D was almost similar size due to length-wide contraction. After that who will come? Then again these are same period. So O minus 2 will be more than F minus. So selenium, iodine, O2 illa, this is also wrong, this is also wrong. I think let us see here, I, Se, Br, O, yes. So D option is the right option. Okay, let us see question number 10. So first of all, we will arrange sulfur, nitrogen, beryllium, magnesium, aluminum. Beryllium will be here. Then before beryllium, our magnesium. Then after beryllium, here boron, and before below boron, aluminum. Then we have our carbon, then nitrogen, then oxygen, and keel oxygen, sulfur. So what is given here? Beryllium, magnesium, aluminum, boron ille, carbon ille, nitrogen, oxygen ille, sulfur, and then sulfur. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yeah. Now we know left to right size decrease and down the group size increase. So pakka this third period will have more size than second period without any doubt. So third period will come first, right? Okay. Now left to right size decrease. So magnesium more than aluminum, more than sulfur. So I will say magnesium more than aluminum, more than sulfur. So this is our third period. Okay. After third we will go to second period. So beryllium more than nitrogen. Beryllium more than nitrogen. So which option? D option. Okay. The incorrect order of ionic size is, okay, La, Gd, Eu, array. Here itself we can see. So you should remember the series. So La and then Eu and then Gd will come, right? So left to right our size decreases. So Eu is more than Gd. So here it is wrong. So incorrect. So A option itself is wrong. Okay. Let us see the B option. So plus 2, plus 3, plus 4, plus 5, charge increase, size decrease. So this is correct. Answer is correct, but order this is correct. plus 2 plus 3. So, thallium and indium. So, keel here indium and then thallium. So, down the group size increases. So, thallium will be more. This is also right order, plus 3 plus 5 plus 7. This is also right order. This is only incorrect because EU will come here. So, here we have finished our DPP number 4 also. Let us move to DPP number 5. DPP number 5, question number 1. Which one of the following statement is incorrect? Now let us come to ionization energy. So I will give you 1 minute of brief. What is ionization energy? Energy required to remove an electron from an isolated gaseous atom. Left to right, ionization energy increase. Down the group, it will decrease. Wherever you will see nitrogen family, due to half filled, its ionization energy will be more than the corresponding neighboring atom. So, you just remember as a star point, beryllium will jump, nitrogen family will jump. Whenever you are arranging ionization energy, beryllium family and nitrogen family will jump. Okay, let us solve. Ionization enthalpy increases for each successive electron. Yeah. So, IE3 will be more than IE2, more than IE1. This is correct. Incorrect they are asking. Next, the greatest increase in ionization energy is experienced on removal of electron from core noble gas. Yeah, just now I have told you. So, why nitrogen and beryllium is jumping? Because nitrogen beryllium is half filled, full filled, more stable. So, ionization energy will be more. It will be more difficult. Okay. So, noble gas is the highest ionization energy. End of valence electron is marked by a big jump. Yes. So, you let us say 5 successive ionization energy is given. You see where is a big jump, that is the ending of valence electron. Okay. Removal of electron from orbital belonging to n lower n value is easier than from the orbital having higher n value. Very wrong. Just now I have told you down the group ionization energy decreases. So, let us say third period and fourth period. So, fourth period will be easier, no? Higher will be easier to remove. Okay. So, D is the incorrect option. Question number 2. The ionization energy of an atom is the energy, just now I have told you, to remove an electron, okay, from an isolated gaseous atom, just enough to cause the electron to escape from isolated gaseous atom. The screening effect of d electron. So, what is the order of screening effect? S, then P, then D, then F. So, D is equal to P, no, much more than P, no, P is more, same as F, no, less than P, yes, ma'am, less than P. So, third D option, okay. Next, in the isoelectronic species, the ionic radii in Armstrong of n minus 3 Ne and Al are. So, just now I have told you ionic size, na? What is the trick? Minus, then neutral, then plus. Okay, let us see here. So, minus 3 will, n minus 3 will be more, then who will come? Neon, and then who will come, bacha? Aluminum. So, n minus 3 means first will be maximum 1.36, no, first should be maximum. So, this is and this wrong. 1.7, 1.4, very good. So, C option is the right option. Let us see question number 5. The covalent and van der Waals radii of hydrogen respectively are. So, we know van der Waals is more than covalent. So, first they are asking covalent, means first option should be lesser and second one value should be more. So, 0.3, 0.8, yeah, 0.3, 0.3 equal, not equal, no, first more, no, covalent is lesser than van der Waals. So, A option is the right option. The increasing order of atomic radii of the following group of 13 element. So, for 13 element, it is an exceptional one and you have to remember what is the order: thallium, then indium, then aluminum, then gallium. Option number 2 will be the right answer. Next, question number 7. How many of the following radius order are incorrect? Okay, let us see. Nitrogen and then phosphorus, down the group size increases. So, phosphorus should be more. This is wrong. O minus 2, yeah, minus 2 means oxygen fluorine same period, na? So, O minus 2 will be more correct only. Ca2 plus and strontium. So, calcium is here and strontium is here. Down the group it increases. Strontium should be more, wrong. S minus 2 and S sulfur same, it is also wrong. So, minus 2 more charge, more radius. Then S minus 2, yeah, minus 2 will be more. So, how many wrong? 1, 2, 3. So, answer should be 3 are incorrect. Out of 4 radius data, they have given 70, 200, 133, 140. if 100 picometer is radius for calcium 2 plus and other 3 O minus 2 Mg2 plus F minus, select the incorrect. Okay. So, radius of O minus 2 will be more than calcium, correct, only oxygen minus 2 charge, it will be more only. Okay. Radius of F minus less, no, more negative, more size, this is wrong, means right option, incorrect only they are asking, right. Negative will be more. Okay. Okay, fine. So, B is the answer. Among the following species O minus 2, P minus 3, Cl minus, S minus, Ca plus 2, K plus, how many have their ionic size greater than S minus 2? S minus 2 more means pakka they will have more negative charge, and if they have a equal negative charge, so it should belong keel down, it should come. Okay. Let us see here. So, potassium no, calcium no, S minus no, Cl minus no, P minus 3. Okay. So, yeah, definitely P minus 3 will be more, right. So, because it has more charge than S minus 2, then it will be, then oxygen. So, oxygen and sulfur, so sulfur will be more, so this is also wrong. So, only one is only one, P minus 3 have the more size than S minus 2. Now, here we have finished our DPP number 5 also. Now, let us proceed to DPP number 6. The ionization potential 1, 2, 3, 4, 5 of an element is 7.1, 14.3, 34, 46 and 162. The element will be, we have solved this type of question so much like so many times in our class. So, you just see the sudden jump. So, 46 to 162, here we are seeing sudden jump. So, before sudden jump, how many IPs are there? 1, 2, 3, 4, which will be equal to number of valence electrons. So, how many valence electron? 4. And which group have 4 valence electron? 14th group, that is carbon family. Who belongs to carbon family? Silicon. So, means they are talking about silicon element, very easy. Okay. If you do not know the concept, then it is one of the most difficult question. Next, series n minus 3 O minus Na plus series 2, this choose the species with lowest IP from series 1 and highest IP from series 2. How I have given you the trick for size na, minus, neutral, plus, same way we have trick for our IP, ulta trick, plus will be more, then neutral, then minus. So, in the first minus 3, minus and plus, plus will be more. So, from the first species what they are asking, lowest. So, who will be lowest beta? More minus charge, lesser IP. So, n minus 3. So, from here the lowest is n minus 3. Now, let us see, all are plus 1, plus 1, plus 1. So, then we need to arrange. So, carbon, nitrogen, oxygen, okay, and they are talking about plus 1 means one charge we have removed, okay. So, when we are talking here, so carbon electronic configuration will be 2p 2, nitrogen 2p 3, oxygen 2p 4, but when I am removing one electron, then it will become 2p1, it will become 2p2 and it will become 2p3. So, after removing one electron, after making it positive, who is most stable? 2p3 is half filled, most stable, means oxygen. O plus will become maximum, okay, and anyway we know left to right ionization energy increases, okay. But in general, first IP the nitrogen will be more, but here second IP they are asking, so oxygen will be more. So, oxygen O plus, and so option number 1 will be the right answer. Then question number 3, the correct value of ionization energies of SiPClS will be. So, let us arrange, okay. So, silicon come under carbon family, then nitrogen, below nitrogen we will have phosphorus, then we have oxygen, below oxygen we have sulfur, then fluorine we have chlorine. So, silicon, phosphorus, sulfur and chlorine, this is not here, okay. So, we have all these elements. So, we know left to right our ionization energy will increase, okay, and I have told you one trick. What is the trick? Nitrogen family will jump, nitrogen family will jump. So, if I am arranging ionization energy, then it will come chlorine, then who will come after that phosphorus, and after that sulfur, and after that silicon. This will be the order, okay. So, they are talking about silicon, silicon will be the least Anna. So you see in which option the first value is least 1 0, no, this is wrong, 786 equal. Now after that they are talking about phosphorus. Okay, so phosphorus is the like second highest, right? Chlorine will be the maximum, and after that, so means this is talking, this is silicon one, this is phosphorus, this is chlorine energy, and this is sulfur. So phosphorus will be lesser than chlorine. So you see in which option we have phosphorus less than chlorine. Here it is more, so wrong option. Here also, here it is less, but already we have reduced. Here it is less, and here also it is less. So phosphorus should be less only. So means C and D both. Then here 1 2 5 6. Okay, chlorine is the maximum. So chlorine is the maximum beta. Here maximum 11. So C option is the right option. Okay. Next, which of the following order is correct? And if you are feeling difficulty, na, so then you write down chlorine is maximum. What is the maximum value? 1 2 5 6. So you write down, choose from here and write down and then rearrange both ways. Okay. Which of the following order is correct for the first ionization potential of boron, carbon and nitrogen? So we know left to right ionization energy increases. So nitrogen, carbon, boron. Where is nitrogen, carbon, boron? Question number 4th, B option. The ionization energy of an atom is the energy needed to remove an electron. Okay. So question number 5, needed to add electron, transfer, convert. D option will be right then. Enough to cause electron to escape from isolated gaseous atom. Question number 6, A plus, first ionization energy, A plus 2, A2 plus, second ionization energy. The energy required to pull out first and second electron, okay, the correct relationship between two energies would be, so we know successive ionization energy is more, so E3 more than E2 more than E1, so E2 more than E1, E2 more than E1, option number 1. The incorrect statement among the following is, the first ionization potential of aluminum is less than the first ionization energy of magnesium. So, our magnesium will be here, and then here boron, and then here we have aluminum. So, I have told you we have jump in beryllium family and then nitrogen family. So, beryllium family will jump, means pakka magnesium will have more energy than aluminum. This is what they are saying. Aluminum is less than magnesium. Yes, it is correct. What they are asking, incorrect. The second ionization potential of magnesium is greater than second ionization potential of sodium. So, sodium and magnesium, second ionization potential energy they are asking. So, we need to remove one electron. Sodium, magnesium. Okay, va? So, sodium is our 11 and it is our 12. So, sodium electronic configuration will be 1s, 2s, 2p, 3s, 1. Okay, va? It will be our 3s1 and it will be our 3s2. If you will remove one electron, so after 3s1 who will come for sodium? Sodium will become 2p3, 2p3. Okay, va? Sorry, 2p3, 2p6, now 1s, 2s, 2p6, 3s2. 3s1. So 2p6, 2p6 bacha, and here this will come 2p3, it will come 3s1. Okay, after removing 3s2 one electron, it will become 3s1 and it will become 2p6. So 2p6 is our inert gas, right, most stable. So that will have highest ionization energy. So in second, sodium will be more higher than magnesium. So magnesium is greater, sodium is greater. Okay, so B option is the incorrect option. Then question number 8, which of the following represent the correct order of increasing first ionization enthalpy for calcium, barium, selenium, sulfur, selenium, argon? So we need to arrange it. So beryllium, magnesium, calcium, strontium, and then barium. So from here we needed calcium and barium, remaining thing is waste. Okay, so calcium, barium I have arranged. Then what I need to arrange? Sulfur, oxygen, sulfur, and then selenium. Oxygen not required, sulfur and selenium required, and then here neon, here we have argon, argon is required. They are asking ionization energy. So left to right ionization energy increases and down the group ionization energy decreases. So pakka barium will be least. Okay, ba? And then after barium who will be least? Calcium and selenium, and here to here ionization energy increases, and we know beryllium family will have a jump. So calcium will be more than selenium. So calcium and then selenium. Okay, this is over. Now we have to compare between sulfur and argon. Definitely argon will be maximum and then sulfur. So argon, sulfur, selenium, which option? D option is the right option. Now let us see which of the following statement is incorrect in relation to ionization enthalpy. Incorrect. Ionization enthalpy increases for each successive electron. Yeah, I3 more than I2 more than I1. The greatest increase in ionization enthalpy is experienced on removal of electron from core. Same answer, same question is repeated, right? Then I think this will be the wrong option. No? Lower n value is easier, higher n value is easier. Down the group, ionization energy decrease. Okay, let us solve question number 10. The decreasing order of second ionization energy for potassium, then calcium and then barium killer. Down the group ionization energy decrease, so pakka barium will be least, and left to right ionization energy increase, and here we don't have nitrogen or something exceptional one. So barium, so maximum calcium, then we will have no, wait a minute. So it is our potassium na beta, and it is our calcium. So when second ionization energy, whenever second ionization energy not do electronic confusion, I can judge no calcium, potassium it is there, so it is S1. As soon as I will remove one electron, it will attain the P6, that is noble gas, so it will become the maximum most, right? So it will click in my mind, but for you as a student you should write down configuration, remove electron and then do it. Okay, so after removing for second ionization energy P6 have attained na, so potassium will become maximum. So our answer should be potassium, calcium and barium. 10th A option. Okay. 11th, in the second period of periodic table, the ionization potential of element increases from left to right. So why the ionization potential increases? Because the Z effective increases, so the size decreases, so ionization energy increases. Increase in density, reactivity, decrease in atomic size, electronegativity. Okay. The correct order of ionization energy for the following species. So they have given the charge. So for charge, what I have told you, plus, neutral and then minus. So where is plus, neutral, minus? Plus, neutral, minus. Question number 12, D answer. Question number 13, for an atom of scandium, which of its ionization energy will be greatest? First, second, third, fourth beta. Na? So successive ionization energy will be increasing. So 13th, fourth will be the answer. So here we have finished our DPP number 6 also. Now let us move to DPP number 7. So question number 1, the correct order of first ionization energy, okay, boron family, I have told you boron family is an exception, please remember. A option will be the right option. I have taught you using this trick, the W trick, okay. Indium and then Thailand, okay. So boron, then thallium, then gallium, then we will have, it will be like this, indium, okay, and then we have aluminum, okay, aluminum and then indium. So option number A. Now which of the following order are correct for the ionization energy? Okay, so let us see, barium, strontium and calcium, beryllium, magnesium, calcium, strontium. Okay, so down the group ionization energy decrease. Okay, wow. So calcium and then we have here barium also. So calcium, strontium and then barium, this is right. They are asking correct only, so first is correct. So next, beryllium, nitrogen and neon. Okay, beryllium, then here we will have nitrogen and then here we will have neon. We know left to right ionization energy will increase. Okay, so yeah, this is also right option. Next, carbon, nitrogen, oxygen, and we know nitrogen will jump, so this is also right. Magnesium, aluminum and silicon. So we know magnesium will jump, beryllium family and nitrogen will jump from their corresponding. So fourth is wrong. So 1, 2, 3 is the right option. Question number 3. First, second of magnesium are given. The enthalpy required for the reaction Mg2 plus 2 electron. So first and second ionization energy is given. So first ionization energy means magnesium removing one electron, I am getting Mg plus 1. From Mg plus 1 removing one more electron, so getting Mg plus 2. So first ionization energy and second ionization energy is given as 178 and 348. They are asking you magnesium to magnesium 2 plus. So, what I will do? I will add these two, right. So, 178 plus 348. So, I will get here 526 option. Question number 3. Find the total number of cation for which ionization potential of cation is lower than chumma question very bad, 0 answer, right. How the ionization potential energy will be lower for corresponding atoms, right, and the two like first one. So, like sorry like corresponding means they are talking about that third lower than second, not possible. Okay, one more time I will read the question. Find the total number of cation for which IP of cation is lower than corresponding atom. They are saying that cation is lower than K, O plus is lower than O. How it is possible? Not at all possible. We know K means first IP, K plus means second IP. Second IP will be pakka more than the first IP. Okay, so 0. The electronic configuration of the element with maximum electron affinity. So, now we are going to see electron affinity. Electron affinity is tendency to add electron. Okay. Electron affinity for nitrogen, for helium, neon, argon, krypton and for beryllium family will be least, right, due to most stable half filled full filled electronic configuration. It will be the least one. Okay. So, wherever you are seeing beryllium, nitrogen, neon, keep it at the end most positive electron affinity. Okay. So, how we will solve? And it is also same as ionization energy, left to right electron affinity increase, down the group electron affinity will decrease. Okay. So, 1s2, 2s2, 2p3, 3, 2, 5, 6, 7 means it is our nitrogen, 1s, 2s, 2p, then it is our fluorine. Then question number, the next sixth option is 10, then 17 and then 1s, 2s, 2p6, 3s2, 3p3, 10 and then here 15. Okay, fine. So, here the question is maximum electron affinity. Please remember chlorine has the maximum electron affinity. Chlorine has the maximum electron affinity. So, which electronic configuration correspond to chlorine? 17. So, C is the right answer. Next, which is correct order for electron gain enthalpy? Just now I have told you chlorine is the highest. Which option has chlorine highest? B option. Directly you can take. The order of first electron affinity of oxygen, sulfur and selenium is oxygen, sulfur and selenium. Please here it is an exceptional one. Remember oxygen will be least. Okay, and down the group electron affinity decreases. Okay, so sulfur will be more than selenium and then oxygen will come. So, sulfur, selenium, oxygen. Question number 7th, B option. Okay, now let us see question number 8. Electron affinity is the energy released when electron is added to an isolated atom. Yeah, it is our electron affinity, tendency to add an electron. Question number 9. The electron affinity value of x, y, z are this, this and this respectively. Okay, va? So, 349 is the highest and highest is for chlorine. So, means x is our chlorine. So, we are talking about fluorine, chlorine, bromine. So, how it will be arranged? Chlorine will be more than fluorine and then bromine. Okay, va? So, we will have our chlorine, then we will have fluorine and then we will have bromine. Okay, so this is chlorine, then 333 means it is our fluorine and then it is our bromine. Okay, so chlorine, fluorine, bromine, question number 9th, B option. So here we have finished our DPP number 7. Now let us move to DPP number 8. So now let us move to DPP number 8, question number 1. The formation of the oxide ion O minus 2 require first an exothermic and then an endothermic step. Okay, fine. This is because oxygen is more electronegative. Just now I have told you, now so many times I have taught you, because oxygen ion will tend to resist the addition of another electron. It has already negative electron repulsion will be there. So, it will resist the addition of another electron. Which of the following has least electron affinity? Okay. So, argon, the noble gas, I have told you the noble gas, the argon will have the least electron affinity. Okay, va? Which of the and most is for chlorine. In this argon is the only noble gas, so argon we have ticked. Which of the following element has highest electron affinity? Chlorine has the highest. Electron affinity depends on nuclear charge, atomic number, atomic size and nuclear charge both. Fourth D option. Okay, va? Now let us see question number 5. The correct order of electron affinity of boron, carbon, nitrogen, oxygen is, so I have told you wherever you will see beryllium family, nitrogen family, helium neon family, it will have the last worst type of electron affinity, half filled, full filled. Okay. So nitrogen will be the last, this nitrogen, here we have last, remaining you arrange. So left to right electron affinity will increase. So oxygen will be more, then carbon, then boron, and then last nitrogen. So fifth C is the right answer. Next question number 6. In which case the energy is not released. So you please remember as a star point, beryllium family, nitrogen family, helium, neon, argon, krypton family, energy is not released, energy is absorbed. Delta H will be positive. Okay. So option number C. Question number 7. Select correct order of electron affinity. Okay, fine. Let us see. So correct order of electron affinity. First we need to arrange it. So oxygen, sulfur. Here we have nitrogen, and below nitrogen phosphorus. Then what else they have given? Calcium. Calcium will be somewhere here. Okay. So we know left to right electron affinity increases and down the group electron affinity decreases. Okay. So decreasing means calcium will be the least. In which option? Every three option calcium is the least. After that, here to here it increase, and I have told you one more thing beta, phosphorus nitrogen family, right, and beryllium calcium family, you know, this will be the worst only. So calcium worst, phosphorus, after calcium who will come? Phosphorus. So here also phosphorus, here also phosphorus, this is wrong. Then A and B. Then after that down the group decreases. Okay, va? But we know that third period will have more than second period, and oxygen anyway exceptional, the last one come under sulfur. So below sulfur it will come. So sulfur will be more than oxygen. So question number 7 B answer. It was a good answer, good question. So many exceptions you have to remember, like so many concepts you have to observe to solve this question. Sulfur, then oxygen wala point, then phosphorus, nitrogen family half filled point, beryllium, calcium, so many things you have to see together. Okay, so let us match it. Iodine, bromine, so down the group size increases. So iodine more than bromine, chlorine, fluorine. So 1Q, 1Q, 1Q. So this is wrong. Next, this is how you should proceed. Match the column question in your exam. Fluorine, chlorine, bromine, iodine. So fluorine is more. Fluorine is more. Yeah, we can see it is ionization energy, right? Because down the group ionization energy decrease, and no exception is also there. So we can say 2P. Here 2P and here 2P means D option is wrong. Next, chlorine is more than fluorine means third period is more than second period, electron affinity they are talking. So third R, 3R, 3R, okay fine. So 3R, A option is the right option. Okay. Now let us see what is the value of electron gain enthalpy of Na plus if ionization energy is 5.1. So electron affinity will be minus 5.1. Okay, ulta. So you remember electron affinity magnitude is equal to magnitude of ionization energy, but sign will be ulta. So plus 5.1, so minus 5.1. So here we have finished our DPP number 8. Now let us proceed towards the DPP number 9, the last DPP. Process Na plus gas. Okay. So here we are adding one electron, and then so it is our electron affinity, and then gas to solid. Okay, fine. So in both the cases energy will be released. So first electron affinity is exothermic, energy will be released, and gas to solid when we are going. So gas atoms are far, okay, energy will be less, and when we are so energy will be more, okay, and when we are going to solid energy lattice energy is very less. So if energy is less means what we should do, energy we have to release, then only energy for solid will become less. So gas to solid, energy released. In the formation of a chlorine ion, okay, from an isolated gaseous chlorine atom, 3.8 electron energy is released, which would be equal to, just now I have told you. So, we have to make chloride ions. So, they are talking about Cl to Cl minus, means we are adding one electron. Okay, va? So, it should be equal to what? Ionization potential of Cl minus. Find the number of element having lower second electron affinity than first electron affinity. Okay, fine. So, they are saying the number of element having lower EA2 than the lower EA1. So, how we will solve all this question? So, EA1 is always exothermic, delta H will be negative. EA2 for a neutral atom or cation, EA2 is always positive, endothermic. So, they are saying that lower EA2, okay. So, EA2 will be pakka lower than EA1, okay, for neutral case, means 1, 2, 3, 4, 5, 6, 7, 8, 9, all the 9 cases. So, answer will be 9, okay. So, EA2 will be always lesser than EA1 for neutral cases. It is electron affinity there, but ionization energy, what I have told you bacha, successive ionization energy will be more, but electron affinity will be less. The electronegativity order of OFCl-Br, electronegativity. So, left to right electronegativity will increase, okay va. So, here we will have nitrogen, then below fluorine we have chlorine, then we have bromine. So, left to right increases. So, fluorine maximum, that is 4, then we will have our oxygen, okay, this is not there, then chlorine and then bromine. So, fluorine, oxygen, chlorine, bromine, fourth A option. Then we have question number 5. For the formation of covalent bond, the difference in the value of electronegativity should be. So, please remember this as a star point, okay. So, for the formation of covalent bond, the electronegativity difference should be less than 1.7. Element whose electronegativity are 1.2 and 3 form. So, we will take the difference. So, 3 minus 1.2, okay. So, it will become 1.8, okay va. So, 1.8 is more than 1.7, means they will form ionic bond, not covalent. Less than 1.7 covalent, more than 1.7 ionic bond. Sorry. The electronic configuration of most electronegative element is fluorine, atomic number 9. So, 2 to 4, 4 plus 5, 9. So, 7th A option is the right option. Which of the following relation is correct? Okay. So, here we have a formula, electronegativity is equal to ionization energy plus electron affinity by 2. Okay, so if we will rearrange it, so 2 electronegativity equal to ionization energy plus electro affinity. If we will bring it this side, so 2 electronegativity minus ionization energy minus electron affinity equal to 0. Which option? Second option. Okay. So, here we have finished all the 9 DPPs, that is almost 90 questions. So, I hope you have learnt a lot. Keep on practicing, revise again and again. So, soon I will bring next NEET PYQ of periodic table, then I will bring JEE PYQ of periodic table. So, those who are my student, they are supposed to do NEET DPP, then NEET practice sheet of 45 question, then advanced NEET practice sheet of 60 question, then NEET PYQ, then JEE PYQ, 5 sources you have to follow, and after that only just like after that only your chapter is prepared. Those who are not studying from me, see my short lectures and then do how much you can do, okay. At least make sure that you are solving DPP's question plus NEET PYQ and JEE PYQ. Thank you so much. All the best.